Hello, you absolute legends. I am Eric Choi, and I'm going to be explaining the explainer video for section 5. And cue. Alright, jumping right in. The problem says a sensitive gravimeter at a mountain observatory finds that the free fall acceleration is 0.0075 meters per second squared less than that at sea level. What is the observatory's altitude? Now, as you can see here, I already wrote stuff down. I didn't want to waste your time with me writing out the problem slowly and kind of segmenting the problem. So here we go. My philosophy for these kind of problems, or any problem really, is trying to find the foundation to solve the problem. So first off, we have to find out what it's asking. We know that there's a difference in height between the observatory and sea level that caused a change in the G value. Thus, it's hinting at us to use a different equation that also includes the height of the observatory that we're trying to find, as you can see right here. The only difference between the regular equation that we're used to and this one is the addition of h in the denominator. Okay, so post-edit cut, I kind of forgot to scroll to the side and show you the drawing that I actually made for this problem. So just imagine this is the Earth and this is the sea level, and on top right here is the mountain with the observatory. And due to this difference in height between the sea level and the observatory, there's a difference in G value found here and down here. And yeah. Okay, now we have to think about the given values that we're going to use to plug in at the end. So, we know that the G observatory value is 0.0075 less than the regular G value. So, that's going to be a grand total of 9.7925 meters per second squared. And the given values from the book is radius of the Earth 6.37 times 10 to the 6. Now note here that I'm not going to make you use the mass of the Earth or the gravitational constant, because those are rather big numbers that might make you get an error if you put into the calculator wrong, as I did earlier when I tried to solve this using a different method. So you'll see in the setup. G observed is gm over r plus h squared. In my first attempt at the problem, I thought I could just find the h of the observatory by plugging in all the values I knew and getting all the values like the mass of the Earth, the gravitational constant, and the radius from Google, as everybody does. But that turned into a whole mess with the calculator, so I thought of a new way. So if we just use the G observed and divide it by G, and use both the formulas that we have right here, you may notice that the gravitational constant and the mass of the Earth actually cancel out, which makes our lives a ton easier. Which leaves us with the radius of the Earth squared over the radius plus the height of the observatory squared. And I explained my reasoning right here, even though I explained it just now. And at this point, using this equation, all we have to do is isolate out that h value right there, which is the final answer we're looking for. And as you can see right here, I'm cross-multiplied. I divided this out, square root both sides, and finally subtract out the radius over to this side. At this point, you're basically almost done. Now, we go all the way up here to our toolbox and find the values that we found earlier, and simply plug and chug them into the calculator. Hopefully you don't mess up a value and have to rewrite it, but it should end up something close to this. Note that our answers might be different if you use different values that you found from Google, the textbook, or from other sources to use the gravitational constant, radius of the Earth, or something else, because they could be estimated differently. But that is the major gist of how to solve the problem, and thank you for listening. Have a nice day, you absolute legends.